Hey guys, and welcome to another video. In this video, what we're going to be doing is we're continuing our differentiation journey, and we're looking at an example where you have to find the coordinates on a curve, but you're given a gradient. So my previous video was where you had to find the equation of a line or a tangent, where you had to differentiate first to find the gradient and then to find your intercept and then find your rule. But in this case, you're actually told the gradient, but you aren't given any points. So it kind of changes a lot. It's a bit squiggly, a bit funny. Now, let's get into it. So find the coordinates of any points on a curve y equals x cubed, take 4x squared, take 2x plus 10, where the gradient is 1. So you're told the gradient. So if you're given your little graph and you know at a specific point the gradient's 1, is asking you which points. Okay, now if you see the word gradient and a function that is not linear, first thing to do is differentiate. So let's differentiate it. dy dx is equal to 3x squared, take 8x, take 2. So if you're not sure about how I got that answer, go back to a few videos to some of my differentiation basics, just so you can have a bit of a debrief on how differentiation works. But I'm moving on. Okay, so my first step is to differentiate. My next step is to now substitute in my gradient. So previously I would substitute in my x coordinate, but you're not actually given any coordinates. You're trying to find them. So I'm going to substitute my gradient of 1. Now, where do I substitute it in? If we remember, dy dx is the gradient function. So we are going to substitute dy dx for 1. So 1 equals 3x squared, take 8x, take 2. So I'm going to substitute the gradient for dy dx. My next part is I'm going to now solve for x. So I'm going to find the x coordinates. You're going to solve for the x coordinates, or the x coordinate, sorry. And then we can find the y coordinate. Okay, so let's bring this over here because I'm going to use the null factor law. So I'm going to rewrite this. Take 2, and then this is subtracting 1. So subtracting 3 in total. Now let's try and now write this in root form or factorize it. Okay, now to factorize a non-monic quadratic, let's look into this. Now, the way you do this is you try and find so you multiply the first and last coefficients or terms. 3 times 3 is 9. You want two numbers that multiply to equal negative 9, by the way, because there's a negative in the front. If it was a plus, it'd be positive 9. But you want it to add to equal negative 8. So you're going to go through your factors of 9 and figure out which factors actually multiply to give you 9 but add to give you 8. Okay, so let's have a look. So 1 and 9 are factors, or 3. Okay, 3 and 3. Now 3 plus 3, or 3 take 3, no matter what combination you have, you'll never get negative 8. So that is not an option that we want. But we're going to delve into this one here. We can have a few options, right? Because we want it to equal negative 9. So those are the two ways we can have it. Now let's check which one will add to give you negative 8. Negative 1 plus 9 will give you positive 8. Positive 1 take 9 will give you negative 8. So we're using those factors. So that means I'm going to rewrite this as 3x squared. So I'm going to keep that first bit. I didn't change that. Now I'm going to rewrite negative 8x in terms of these factors. So that's the same as saying 1x take 9x. Sorry, positive 1x. That's a plus. Because if you check, if you put those together, 1 take 9x gives you negative 8x. Okay? And then I'm going to keep that 3 on the end. Okay? Here we go. So now what we're going to do is I'm going to now factor. I'm going to split it in half almost and factor each one separately. So the highest common factor between these two terms is x. So x times by 3x gives me 3x squared. X times by 1 gives me 1x. I'm going to look at these terms now and see what the highest common factor is. Now, the highest common factor in this case is -3. -3 can go into it. -3 times by 3x gives you -9. -3 times by +1 equals -3. And if you did this right, you will get a common bracket or a common factor. So we're going to factor this part out. So we can rewrite it as 3x plus 1. And essentially you take whatever's left over and put it as your other bracket. So it's going to be x, take 3. Okay, we factorize. Let's split it up. I like to actually physically separate it like this. Make each part equal to 0 and solve for x separately. 3x equals -1, x equals -1/3. That's one of my x coordinates. X equals, if I move this -3 to the other side, my answer is 3. So that means if the gradient was 3, so if I drew my curve, just to give you context back to the original question, let's say, what's my original question? It is a cube. Okay, so let's say we had a cubed function, I don't know, like this. Okay, let's say it means that it will have a gradient of 1 at these points, so at -1/3 and at 3, these points hypothetically would have the gradient of 1. Okay, but we actually need to find the y coordinate of it. Now, a common mistake is you'll take these numbers and substitute it back into this. You are not. You need to find the y coordinate. So we're actually substituting it back into the original. So let's do that. So the original was y equals x cubed, take 4x squared, take 2x plus 10. Let's substitute x equals 1/3. So 1/3. Oops, I need to put my negatives in there. Now you can chuck that straight in a calculator. You do what you will with it. Now I'll come up with a funky number. I'm just going to leave it as a fraction. The fraction would be 275/24. Absolutely, you can leave it as a decimal. But I find that when you write it as a fraction, it leaves it as an exact answer. So there's no rounding involved. It's the most accurate answer. So yes, you can round, but it's not going to give you the most accurate answer. Because often when it comes to a fraction, you often get a lot of decimal places and you have to round. In this circumstance, because I want specifically where the coordinate is, I will leave it in exact form, which is in this case a fraction. So that means one of my coordinates where the gradient is 1 is here. So that's one of my answers. Let's do it for the other one. So I did it for 1/3, -1/3. I need to do it for this one too. Okay, so I'm going to substitute x equals 3. That means y equals, what's my original? 3 cubed, take 3 squared, take 2 to the power of 2 times 3 plus 10. So if I put it into my calculator, I'll work it out, your answer is -5. So my other coordinate is 3, -5. So that means my answer, therefore, at coordinates -1/3, 75/24, and 3, -5, the gradient is 1 on the function y equals x cubed, take 4x squared. So this is like the worded answer version. This is just in full, okay? So that means those two coordinates, the gradient is 1 on the function that you were given in the beginning. I know, very lengthy, but let's break down. Let's go back and summarize what we've done. So we differentiated first. We substituted in the gradient for dy dx. We solved for x. Here, our step 4 was to substitute the x values back into the original function. And then step 5 is answer the question, which I've written in full. Now, hard to know, but most people will just leave their functions as long as you indicate your answers really clearly, like I have in highlighter. That's usually suffice. If it's in a contextual question, like it's talking about the bounce of a ball and it's telling you when it hits the ground or something specific like that, I would write it as a worded question, worded answer. But in this case, you could technically just write the 2 coordinates and really clearly indicate it, and you'd be fine. All right. Thanks very much, guys, for watching, and I'll see you next time. Bye.